Blockchain is a database designed to record and verify transactions without relying on a single entity, like a bank. It's secure, efficient, and transparent. This makes it an attractive solution for keeping financial data away from hackers. Shortly, we'll be using it more and more in our day-to-day lives. Several banks have already begun experimenting with blockchain technology. The current common wisdom is combining the benefits of a traditional relational model of a distributed database with those of a blockchain database. This is the case even though forward-thinking individuals and businesses are working to circumvent the current limitations of a database based solely on blockchain technology. BigchainDB is one of the companies helping to pave the way with this combined distributed and blockchain database model. With the help of this combined software stack, the most beneficial aspects of both kinds of technology will be able to be incorporated into a single database. The database will have decentralized administration, data integrity, and enhanced assets due to the blockchain stack, and it will offer adaptability and faster data processing speeds due to the distributed database. Making certain that the database has multiple administrators who control how the data is shared is essential to the successful execution of such a hybrid model. This will make it possible for the database to keep the characteristics of a blockchain database associated with decentralization while still functioning as a distributed database. Blockchain database basics. To understand blockchain databases, you first have to understand databases, which are essentially data collections that need to be organized and maintained. A database is made up of tables, fields, and indexes. Tables are where the data is stored. The purpose of a table is to organize data so that all rows in the table contain the same type of value. Each field contains data that either identifies or contains information about an object. In a database, an index is a list of fields that a table can use to find data efficiently in the table. Dictionaries are another type of database. In its simplest form, a dictionary stores the definitions for known words like apple and cat. Dictionaries can store values and definitions, so there is still some ambiguity involved when looking up the value from the dictionary. For example, the dictionary may contain a value in the data field for each word that indicates how often that word is used. Combining databases with blockchains. Blockchain is important because it enables simple, transparent, and secure peer-to-peer transactions. The blockchain is a decentralized, distributed ledger of digitally recorded data verified by multiple independent sources. Each block in the blockchain contains a hash pointer, transaction data, and metadata. The hash pointer is simply a link to the previous block in the chain, thereby creating a chain of blocks. A hash pointer is used to verify each transaction block, making it nearly impossible for hackers to alter the data stored on any block. Multiple copies of the blockchain database exist at all times, eliminating any possibility that hackers can alter one single copy and change it from a legitimate database. Ways to create a blockchain database. Operational blockchain data store with business. The blockchain database is a new technology that looks like the future. It is an alternative to databases such as Oracle, SQL Server, MySQL, MongoDB, etc. The blockchain database exists in a distributed manner, helping users keep all their data in one place without any third-party interference. But there are certain ways by which we can create a blockchain database. An operational data store, or ODS, is used for operational reporting and decision-making. The data collected will represent all information obtained from business operations not engaged with the blockchain database in our consolidated, distributed, and blockchain stack dataset. This is a preferable way to create a blockchain database. Non-operational blockchain data with enterprise. The blockchain database is similar to a traditional database, except that it can be distributed across multiple computers instead of being centralized. This means that it may only be ideal for some processes and businesses. So to use the blockchain database regularly, a distributed database, or DB, is necessary. Now in this way, all data will be stored in one place, but there are certain disadvantages too. Combined database. Sometimes, data from the blockchain database can be put into a traditional database and vice versa. This is a very creative idea of using traditional databases and blockchain technology in one place. This is one of the most brilliant ways to create a blockchain database. We can have complete flexibility in this solution too. But we need to be careful in ensuring that there will be no unwanted data on the transactions. Operational blockchain data with consortium. Hackers can never be at ease when dealing with a database made up of blockchain technology. This is one of the most popular methods by which one can create a blockchain database. In this kind of data, there will be certain flaws and weaknesses that software engineers cannot fix. This is because all the data is held in one place, and no single party controls it. So all the data must be checked thoroughly before it gets distributed among all the parties concerned, including an enterprise. Non-operational blockchain data with consortium. Non-operational blockchain data is the most preferred way of storing data in a consortium database. With this type of data, we will not be able to make any changes to the database. A specific group can only access a non-operational blockchain database, and no one else is allowed to access or modify the database. This kind of data is also protected from hacking attacks. Combined blockchain configuration. We can have an additional configuration with a combination of operational and non-operational data in a consortium database. This way, all parties can maintain the security of their data while keeping it safe from any external interference. This is also known as a hybrid configuration of a blockchain database. Conclusion. So, in short, a blockchain database is an application made up of data blocks stored across a network. It's based on the decentralized ledger system. Blockchain can store executable codes and documents, making financial transactions faster and more transparent. Thus, blockchain database has become one of the most popular technologies in the world. We can also use it for storing information about products and other relevant information related to a particular business. Thus, blockchain database plays a prominent role in any business today.